Can you believe it? A dinosaur no bigger than a Labrador once darted through the feet of giants, and it was just recently discovered. In a prehistoric world ruled by massive creatures towering like skyscrapers, a tiny, swift and surprisingly clever dinosaur managed to survive by staying small and moving fast. It didn't roar or trample. It simply ran, dodged and hid. Meet Enigmacursor, mollyborthwickae, the newly identified dog-sized dinosaur that's surprising scientists around the globe. Roughly 150 million years ago, during the late Jurassic period, Earth looked drastically different from today. It was a vibrant, humid planet covered in dense coniferous forests, fern prairies and shallow inland seas. The air was thick with moisture, and volcanic activity occasionally reshaped entire landscapes. Dinosaurs of colossal proportions like Stegosaurus, Diplodocus and Brachiosaurus dominated these ecosystems, towering over the terrain like living skyscrapers. But hidden beneath their shadow, weaving between their massive legs, was a much smaller and, until recently, largely unrecognized creature, Enigmacursor mollyborthwickae. This little dinosaur, standing just about 2 feet tall and measuring roughly 6 feet in length from nose to tail, had a build much more suited for speed than strength. Its very name, Enigmacursor, translates to mysterious runner. This isn't just a poetic flourish. It reflects the animal's likely survival strategy, staying swift, nimble and unnoticed. The second part of its name, mollyborthwickae, honors Molly Borthwick, a long-time museum volunteer who supported the research that led to the dinosaur's identification. It's a fitting tribute to someone who, much like this little runner, may have been overlooked by the spotlight, but played a vital role in discovery. The fossil of Enigmacursor was unearthed in what is now the state of Colorado, in a fossil-rich formation that has yielded many famous dinosaurs over the years. For decades, its bones were misidentified as belonging to Nanosaurus, a small herbivorous dinosaur known since the 1800s. But thanks to recent advancements in scanning technology and comparative analysis, paleontologists began to notice differences, particularly in the shape of the vertebrae and the proportions of the hind limbs, that didn't match any known species. These subtle deviations were enough to warrant a new classification, adding a fresh branch to the dinosaur family tree. This moment of reclassification is more than academic bookkeeping. It shows how science evolves. Fossils that have sat quietly in museum drawers for years can take on new life when viewed through modern lenses. What was once overlooked can become the key to rewriting a chapter of prehistoric history. What makes Enigmacursor so fascinating is not just its small stature, but the role it may have played in its environment. Rather than dominating through size or strength, it may have acted as a quick-footed forager, darting through low vegetation and feeding on ferns, cycads, and other ancient plants. It likely relied on its speed and awareness to avoid predators like Allosaurus or ancient crocodilians, making it more of a sprinter than a fighter. Some scientists speculate that its social behavior may have included moving in small groups or family units, an early example of cooperative living in dinosaurs. In many ways, Enigmacursor forces us to expand our understanding of dinosaur ecosystems. The Jurassic wasn't just the age of giants. It was a time of ecological diversity and niche specialization. Tiny herbivores like Enigmacursor likely served essential roles, such as spreading plant seeds, maintaining undergrowth, or serving as prey for medium-sized predators. Its discovery is a reminder that even the smallest pieces of the puzzle are crucial to seeing the whole picture. This find also carries a human message. Just as Enigmacursor had been hiding in plain sight, so too do opportunities for discovery sometimes rest in front of us, waiting for the right moment or the right eyes to recognize them. In the grand story of life on Earth, every creature has its role, and sometimes the quietest runners have the most enduring stories to tell. Enigmacursor mollyborthwickae may have been small, but its skeleton offers a vivid glimpse into a life honed by evolution for speed, agility, and survival. In a world where many of its neighbors were massive and lumbering, Enigmacursor thrived with the opposite approach, staying fast, alert, and light on its feet. Its anatomy reads like a blueprint for outmaneuvering threats rather than overpowering them. Perhaps the most eye-catching part of its anatomy is its long, slender hind limbs. These were not just proportionally large, they were biomechanically built for rapid acceleration and sustained movement. Their length and joint structure suggest Enigmacursor could spring into motion at a moment's notice, which would have been invaluable in dense Jurassic vegetation filled with ambush predators. Its narrow feet, likely equipped with clawed toes, provided excellent traction on the soft, uneven ground. Combined with strong leg muscles, these features suggest it may have been one of the FA's, because test dinosaurs in its size range. The pelvis and hip structure also point to a running-focused design. The configuration allowed for a wide range of motion in the hind limbs and efficient forward propulsion. This would have been useful not only for evading predators like Allosaurus, but also for traversing large areas in search of food or safe resting places. Paleontologists often refer to such build characteristics as cursorial adaptations, meaning they are specifically suited for terrestrial speed and agility. In this regard, Enigmacursor may have occupied a niche similar to modern ground-dwelling birds like roadrunners or small ungulates. In contrast to its powerful hindquarters, its forelimbs were relatively short. While they would not have played a major role in locomotion, they may have served multiple purposes. Some paleontologists speculate that the arms could help with feeding, perhaps holding down plants or helping strip foliage with its hands. Others suggest they could have assisted with balance, grooming, or even subtle communication gestures within small social groups. While direct fossil evidence of behavior is rare, such multi-use adaptations are common among small, agile animals. The skull of Enigmacursor has yet to be fully uncovered, but its closest relatives in the dinosaur lineage give us valuable clues. It most likely had a small head compared to its body, featuring a pointed snout and a beak-like structure adapted for cropping vegetation. The jaws may have been lined with leaf-shaped teeth, suited for slicing through fibrous plants like ferns, cycads, and horsetails. These plants were abundant in the Jurassic landscape, forming a significant part of the diet for many herbivorous species. Inside its skeleton, paleontologists have found further hints at its lifestyle. The vertebrae suggest a high degree of spinal flexibility, enabling quick directional changes, key for dodging predators or navigating forest underbrush. Its long tail likely wasn't using just for show. It probably acted as a counterbalance, allowing it to make sharp turns without losing momentum. This is a strategy seen in many modern fast-moving animals like cheetahs and lizards. The tail may have also served as a visual signal or even as a rudder while running. Even the ribs and chest cavity of Enigmacursor suggest a high-performance system. A deep rib cage could have housed well-developed lungs and air sacs, possibly aiding in more efficient respiration during bursts of high-speed movement. Though speculative, it aligns with what we know about other theropods and small herbivorous dinosaurs that required sustained activity levels. All these features together paint a compelling picture. Enigmacursor mollyborthwickae was not an armored tank or a bone-crushing predator. It was a survival specialist. It relied on finely tuned physical traits to stay mobile, stay alert, and stay alive. Rather than dominate through force, it excelled through finesse. Its agility may have helped it forage in tight, low-lying vegetation and avoid becoming a meal itself. Ultimately, Enigmacursor reminds us that evolutionary success doesn't always belong to the largest or most powerful. Sometimes it belongs to the quiet runners, those built not to fight, but to adapt, to evade, and to flourish in the overlooked corners of a vast and ancient world. To truly understand Enigmacursor mollyborthwickae, we have to step into its world, not just what it looked like, but what it sounded like, smelled like, and felt like to be a small, fast-moving creature navigating a landscape dominated by giants. Its story isn't just about bones and measurements, it's about survival, adaptation, and the everyday challenges of living in one of Earth's most dramatic periods. In this vibrant and often dangerous world, Enigmacursor is not a bystander, but a vital part of a complex ecosystem. During the late Jurassic period, roughly 150 million years ago, Western North America was a lush, dynamic environment. A mosaic of river plains, seasonal wetlands, volcanic uplands, and dense fern-filled forests. The climate was warm, humid, and oxygen-rich, conditions that supported a dazzling array of life. Giant conifer trees, cycads, and ginkgos towered above, creating shady canopies that filtered sunlight into dappled patterns across the forest floor. Dragonfly unrolls in a clogged space on the moon. Headless structures are vocal. Outer stark too. We shoot past the showers of trees, its formation to rain, at months in now. Trees. Machinas hard, Brachiostros, Celti of lilies, and rushes, and into trees and martyrs, and possible toils. Nolan the Assemblies. In using style all, Thoreau's welcome. You shall's care plants, in costing from Arsels. And ring to interested, overs 34th and the usual, on the 5 to a fair, and unpeopled rooms. A tox augural lacked the armour, size, or teeth to stand its ground. It had something just as valuable: awareness, speed, and adaptability. Its small stature allowed it to thrive in spaces too cramped or chaotic for larger dinosaurs. Between tree roots, under low foliage, and along narrow stream beds, Enigmacursor could dart and hide where few others could follow. It may have even made use of natural features like hollow logs, thick underbrush, or rocky crevices for shelter. Its diet likely consisted of soft, ground-level vegetation, ferns, horsetails, cycads, and the tender shoots of ancient plants that dominated the Jurassic underbrush. Unlike its towering neighbours, who needed massive quantities of food, Enigmacursor could get by with smaller portions, grazing quietly and efficiently. And because it was small, it could do so without trampling delicate ecosystems, perhaps helping to maintain ecological balance by keeping fast-growing plants in check. Its feeding habits may have also aided in the dispersal of plant spores or seeds, playing a role in the regeneration of the forest. Predators would have viewed Enigmacursor as a quick snack if they could catch it, but catching it would not have been easy. Its strong hind legs, acute senses, and likely fast reaction time made it a difficult target. It's possible it relied not just on running, but also on camouflage and knowledge of its surroundings. Some scientists even suggest it may have had behavioral strategies like freezing in place or zigzagging to escape pursuit. Its coloration, though lost to time, may have helped it blend into dappled light and shadow, making it nearly invisible among the ferns. While we don't yet have direct fossil evidence of group living, many similar dinosaurs exhibit signs of social behavior. It's reasonable to imagine small herds or family groups of Enigmacursor foraging together or keeping watch in shifts. Living in groups could increase their chances of spotting predators early and enhance survival for juveniles. Like birds or meerkats today, social structures might have offered an evolutionary advantage. These groups might have moved in quiet, coordinated bursts, communicating through subtle movements or chirps lost to prehistory. Beyond their biological role, Enigmacursor and creatures like it shaped the very rhythm of life in the Jurassic. Their trails may have formed small pathways in the undergrowth, helping other animals navigate. Their droppings would have fertilized soil, spreading nutrients and perhaps seeds. Every footprint, every bite, every interaction left a mark, however small, on the living system. The collective impact of such tiny herbivores may have helped shape plant diversity and forest structure across entire regions. Too often, our imagination of the prehistoric world is dominated by giants. But ecosystems are complex tapestries, and it's the interplay between big and small, fast and slow, plant eater and predator that creates balance. The discovery of Enigmacursor mollyborthwickae brings depth and subtlety to that picture. It reminds us that evolution doesn't just favor the bold or the brawny. It also rewards those who can move quietly, respond quickly, and blend into the landscape. It also challenges our assumptions about what kinds of creatures matter most in the fossil record. In the quiet, shaded corners of the ancient world, Enigmacursor thrived. It didn't rule its time, but it endured it. And in doing so, It left behind clues that millions of years later would whisper its story to us from the stone, inviting us to see prehistory not just as a battle of giants, but as a living network of life, full of subtlety, strategy, and survival. The discovery of Enigmacursor mollyborthwickae wasn't made during a headline-grabbing dig or uncovered in a thrilling moment of unearthing ancient bones beneath the desert sun. Instead, it happened in a quiet fluorescent-lit room deep inside a museum collection. The bones of this small, swift-footed dinosaur had been sitting in drawers and storage cabinets for decades, catalogued, labelled, and mostly forgotten. Once believed to belong to the already known Nanosaurus, these fragments of history waited silently for someone to look at them differently. What changed wasn't the fossil, but the questions scientists were asking, and the tools they now had to answer them. Today's paleontology is undergoing a quiet revolution. With advances in imaging technology, 3D modeling, CT scanning, and comparative digital databases, researchers can now reassess old fossils in ways that were once unimaginable. Subtle anatomical differences that would have gone unnoticed with the naked eye can now be analyzed in high detail. When scientists returned to this overlooked specimen and began studying it bone by bone, joint by joint, a new image emerged. This wasn't just a variation of a known species, it was something new, something that had slipped through the cracks of the fossil record. This type of rediscovery is becoming increasingly common. Across the globe, museums are filled with fossils collected in the 19th and 20th centuries. Many gathered at a time when classification systems were rudimentary, technologies were limited, and the sheer volume of material outpaced the ability to thoroughly analyze it. In some ways, our museums are like unopened time capsules, filled with potential discoveries just waiting for the right question or the right technology to unlock their secrets. With powerful computing and high-resolution scanning, researchers can now reconstruct entire skeletons digitally, simulate movement, and compare data across continents in seconds. Enigmacursor has become a powerful symbol of this shift. It reminds us that science isn't always about forward momentum. Sometimes progress means pausing, re-examining, and embracing the possibility that something we thought we knew may need rewriting. Scientific knowledge is not carved in stone. It is a living, breathing process of continuous revision. This humble dinosaur embodies that very principle. The rediscovery of Enigmacursor also shines a light on the collaborative spirit of modern science. This wasn't the achievement of a lone genius, but the result of a network of paleontologists, curators, preparators, digital technicians, and volunteers. One of those volunteers was Molly Borthwick, whose behind-the-scenes work earned her a rare honor, the dinosaur's name. Her contribution, though not made under a spotlight, is emblematic of the many unsung heroes who make scientific discovery possible. They are the hands that clean the bones, the eyes that label them, the minds that quietly question. Could this be more than we think? Moreover, this story redefines what we often picture when we think of discovery. Pop culture teaches us to imagine eureka moments, sweaty archaeologists brushing dirt from a fossil as cameras click. But in reality, many scientific breakthroughs unfold not in the field, but in the archives. Discovery can be slow, it can be quiet, and it can come from the simple act of revisiting something familiar with new perspective. Enigmacursor was always there. We just hadn't yet learned how to listen to its story and what a story it tells. For the public, Enigmacursor opens a window into a different kind of dinosaur, one that doesn't roar or tower over the forest, but darts silently beneath it. It invites us to think beyond the biggest and flashiest. In its quiet way, this dinosaur connects us to the essence of science itself: curiosity, patience, and the willingness to challenge what we think we know. It gives young learners a new kind of hero, a dinosaur that wasn't dominant, but still made a difference. It reminds them that even small, unnoticed things can change the way we see the world. Beyond education, Enigmacursor is also a reminder of the fossil record's depth. Every drawer in a museum, every fragment in a box, is a potential doorway into deep time. Some of our greatest insights may be lying in plain sight, waiting for someone to ask the right question. As we develop new tools and frameworks, our ability to interpret ancient life becomes richer, more nuanced, and more human. in the fossil record. As in life, greatness doesn't always come in the form of spectacle. Sometimes it comes in endurance, in persistence, in surviving long enough to be seen again. Enigmacursor may have lived in the shadows of giants, but now it steps into the light, not just as a species, but as a story that whispers from ancient stone, telling us to keep looking, keep questioning, and never underestimate what the past still has to teach us. In a world where giant dinosaurs dominate headlines, documentaries, museum halls, and childhood fantasies, it's easy, perhaps even natural, to overlook the quiet players in the background. Creatures like Enigmacursor mollyborthwickae don't command attention with their size. They don't inspire awe with sharp teeth or armored tails. They don't thunder across ancient plains in cinematic slow motion, and yet their very modesty is what makes their legacy so powerful. In the grand story of life on Earth, not every chapter is a blockbuster. Some are footnotes, some are marginalia, but those soft notes often carry meaning just as deep. Enigmacursor, with its small frame and swift feet, represents one of those whispers, an elegant, indispensable verse in the long evolutionary poem written across the rocks of time. Small dinosaurs like Enigmacursor serve as a critical reminder that prehistoric ecosystems were not just arenas for titans. They were dynamic, multi-layered, interwoven webs of life, much like ecosystems today. While apex predators like Allosaurus or immense herbivores like Diplodocus draw much of the attention, they did not exist in isolation. Their survival, in part, relied on the subtle work of the smaller animals that maintained the undergrowth, dispersed seeds, recycled nutrients, and helped stabilize food chains from below. These were the ecosystem engineers, on a scale we often forget. The ecological importance of small-bodied dinosaurs goes even further. They were incredibly adaptable. Their smaller size, faster metabolisms, and diverse behavioral strategies allowed them to exploit niches inaccessible to larger dinosaurs. They could live on less food, hide more easily, and respond more rapidly to environmental changes. Some likely nested in hidden places, reared young in safety, and used their speed and cunning rather than brute strength to stay alive. Their ability to evolve rapidly in response to shifting conditions made them ideal candidates for long-term survival. From an evolutionary perspective, they were crucial links in the chain. Many paleontologists believe that small theropods with traits similar to Enigmacursor may have eventually given rise to birds. While Enigmacursor itself is not directly on the avian lineage, it shares features: bipedal locomotion, light skeletons, possibly feathers or feather-like structures that point to this remarkable evolutionary bridge. Studying creatures like it helps us understand how one of the most astonishing transitions in Earth's history occurred, from ground-dwelling reptiles to sky-soaring birds. But if small dinosaurs are so important, why do we know so little about them? The answer lies in the fossil record itself. Preservation is not an equal opportunity process. Delicate skeletons are less likely to fossilize than massive ones. Smaller bones are more likely to be scattered, destroyed, or missed entirely. For every towering skeleton that ends up in a museum, there are countless fragile forms that never fossilize, or if they do, remain buried, fragmented, or misidentified. The record is biased toward the bold, and yet, through persistent research, discoveries like Enigmacursor help correct that imbalance. Each new small dinosaur species discovered expands our view of the Mesozoic world. They help scientists reconstruct the fine-scale details. What did the understory of the forest look like? How did food chains function below the canopy? Which plants were grazed, and how did those plants adapt in response? What was the daily rhythm of movement, feeding, and survival like at a scale most dinosaurs couldn't access? Without animals like Enigmacursor, we'd be looking at an ecological mural with its bottom half erased. And then there's the human story, the symbolic power of the small. Enigmacursor reminds us that being modest in size, in visibility, or in perceived importance does not diminish impact. Greatness can come from persistence, from adaptability, from co-trading leagues, staying light-footed in a world that doesn't always notice you. That lesson extends beyond paleontology. It touches education, conservation, and even the way we view our own roles in society. In classrooms and science centres, children who don't identify with the biggest or loudest creatures can see themselves reflected in something like Enigmacursor, a survivor, a mover, a quiet force that mattered. Its bones, once mislabeled and forgotten in storage, now become a metaphor for the overlooked. They urge us to pay attention to the fragments, to re-examine what we thought we already understood. They encourage curiosity not just about what's missing, but about what's already in front of us, waiting to be seen more clearly. In this way, Enigmacursor does more than fill a gap in the fossil record. It reshapes our sense of what we value, both in science and in life. The legacy of Enigmacursor mollyborthwickae is written not in grandeur but in grace. It lives in the quiet realization that that sometimes the most enduring marks in Earth's story are left not by those who dominated, but by those who endured, adapted, and made their presence known in subtle but lasting ways. In the layers of stone and in the layers of meaning, we find that even the smallest among us have something monumental to say. Enigmacursor mollyborthwickae may not have been fierce or famous, but it thrived in a world of giants. It didn't roar or tower above the trees, yet it survived, quick, alert, and enduring, leaving behind a story written in stone. Through its rediscovery, we've seen how science isn't just about spectacular finds, but about looking closer at what we thought we already knew. This small dinosaur reminds us that ecosystems and scientific breakthroughs depend on more than just the obvious stars. So, when you think of dinosaurs, remember the ones beneath the leaves and between the giant's footsteps. Enigmacursor teaches us that greatness can come from subtlety, and significance doesn't always roar. If this story fascinated you, give us a like, drop a comment, and subscribe for more science stories that reveal the hidden wonders of natural history.